So let's look at our next example. We're told that 4 feet of wire is to be used to form a square and a circle. How much of the wire should be used for the square, and how much should be used for the circle to enclose the maximum total area. All right, so we're using some wire and we're gonna make a square. So let's just go with X for being one side of the square. Well, then the other side is also X. And then I'm gonna make a circle. And a circle, all I need to know about the circle is the radius of that circle, R. So let's add up the area here. The area would be X squared here. What's the area for a circle? It's pi r squared. So we're told to maximize total area. So we want to maximize formula A, the total area, which is X squared plus pi r squared. Okay, and then what constraint do we have here? Well, our constraint is the length of the wire. We only have 4 feet of wire in total to use, so I need to add up the amount of wire used on the square. Well, if I add up the 4 sides, it would be 4x. And then the circumference of this circle will tell us how much wire was used. What's the circumference? It's 2 pi r. So that has to be equal to 4. So I'm going to take my constraint equation and I'm going to solve for r here. So if I solve for r, and divide by 2 pi, r will be, or if you want to simplify down the numbers, 2 minus 2x over pi. And now you're going to plug this into the formula that we were trying to maximize, which was this total area here. So A is x squared plus pi r squared. A will be x squared plus pi. And I'm going to go ahead and factor a 2 out here. 2, 1 minus x over pi squared. And here, x, the smallest x can be, let's talk about our domain real quick. The smallest x can be is 0. And what's the largest? Well, if you look back, I had 4 feet of wire in total, which means the largest x could be is 1. I used the entire wire on the square, so the largest x could be is 1. All right, so now let's simplify this formula for A. 4 over 1 minus x squared, and then it'll be over pi. And if you get a common denominator here, pi x squared. And then if I square that, if I FOIL it out, so A would be 1 over pi pi plus 4 x squared minus 8x plus 4. So now I can take the derivative to find my critical numbers, dA dx. It's 1 over pi, 2 times pi plus 4x minus 8. Set that equal to 0. We're trying to find our critical numbers. So if I multiply both sides by pi, we'll get 2 pi plus 4, x minus 8 equals 0. X will be 8 over 2 times pi plus 4. X will be 4 over pi plus 4. And if you put this into a calculator, it's approximately 0.56. So we found our critical numbers. Now let's plug in our two endpoints into the area formula. So if x is 0, then A would be 4 over pi, which is approximately 1.27. If I plug in this 4 over pi plus 4, just plugging in about, if you plug in 0.56, you'll get approximately 0.56 for the area. If I plug in 1 for the area, we'll be left with 1. So compare these three values. And it looks like we were looking for what? We were looking for the maximum of these. So it looks like our maximum area occurs when x equals 0. So that means we need to use all of the wire is used for the circle. So if we want to maximize our total area, we should use all of the wire to make the circle and use none of it to make the square.